Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week in Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we'll talk about the number one issue that is gripping the headlines. And we're going to talk about immigration, specifically now, how immigration policies of Donald Trump may or may not affect our science and the science establishment that we've created that have given us so many scientific wonders and has been an engine of the economy. We're going to talk about the H-1B visa. We're going to talk about the impact of immigrant scientists on America and American wealth. And we're going to talk about what could happen in the future. And then we're going to say a few things about outer space. A piece of rock from Mars has recently been discovered. In 2012, believe it or not, a piece of Mars slammed into Algeria. Scientists are eagerly analyzing it to give us clues about origin of volcanoes and the atmosphere of Mars itself. And speaking about the weather, we'll say a few things about Larsen Ice Shelf C. As we have been reporting on exploration, there's concern among climatologists that there's going to be a major break in the Antarctic, which could eventually affect the weather and global warming. And so the question is, how close are we to having a piece of ice the size of Delaware break off from the South Pole? Some scientists now say it could only be a matter of weeks to months before we have a break that we haven't seen for perhaps 10,000 years. So let's just jump right into some of the top stories in science. The number one story that is gripping peoples around the world, causing numerous demonstrations on different continents, is the question of immigration. Now, in this hour of exploration, we're not going to talk about the immigration status of 7 Muslim nations whose immigrants have been banned temporarily from entering the United States. We're not going to talk about the controversy of illegal aliens and the undocumented and the wall between the United States and Mexico. Now, today we're going to talk about something that Donald Trump has only hinted at, but we simply don't know what his policies will be, but already it's caused a lot of anxiety at Silicon Valley. You see, Silicon Valley, which generates so much wealth and pride for Americans, is very much subject to immigration laws. You may not know this, but about 50% of Silicon Valley is foreign-born. That's right. Many of them come from Taiwan, China, India, from different places of the earth because of a brain drain into the United States. And that generates wealth. Tremendous wealth coming from Silicon Valley. That's the reason why we have so many billionaires coming from Silicon Valley that live in the Bay Area. So again, about 50% of Silicon Valley consists of foreign-born. Now, you may say to yourself, now, wait a minute, I see Bill Gates on TV, and I don't see the foreign-born. Well, you have to realize that just beneath the layer of the Bill Gates, you'll see lots of Chinese and Indian scientists toiling away, making sure that the ideas of Bill Gates are translated into reality. And so we have a situation where Silicon Valley depends upon a visa. The visa is one of America's secret weapons and is called the H-1B. And the question is, will Trump do something to take away or restrict the H-1B visa, which in turn could restrict scientists from going to Silicon Valley, which in turn could affect wealth generation here and job creation in the United States? Now, to be fair, some people say that the H-1 visa takes jobs away from American workers. And as you know, Donald Trump has made 2 priorities for his administration. Everything else is secondary. First is jobs and job creation. Second is safety, that is restricting terrorists. And so Donald Trump says that we need this temporary ban on these 7 Muslim nations. It's not anti-Muslim, he says, because there are Muslim nations that are not subject to this temporary ban. But some people believe that eventually, though not now, it could affect the status of legal immigration into the United States, because people will say that these jobs are going to aliens when they should go to Americans. Now, here's where the science comes in. It turns out that the level of science we're talking about is very high enough so that there are many jobs that simply go unfilled in the United States. I mean, every year, it seems, Bill Gates goes to the Congress and tells people that we have all these thousands of jobs that cannot be filled because American workers are simply not up to speed. And so it's rather embarrassing to talk about this, but it goes even one step further, back to our educational system. First of all, America has one of the worst science and math educational systems known to science. Our students score dead last, not just this year or last year, but for decades going back into the past. American students have either scored dead last or near dead last in science and math tests when compared to students from China and Singapore and Tokyo and other places. And so there should be a dearth of American scientists. But you may say to yourself, now wait a minute. America still has Silicon Valley. America still generates lots of scientific wonders. We're still the envy of other nations. So what's happening here? Well, it turns out that, yes, our high schools are dismally bad, but we have two things going for us. One thing is college. We do have good colleges. They make up for the fact that we have dismally bad high schools. In fact, the first freshman year in college is basically remedial high school. Now, how do I know this? Because I teach these students. And for me, it's amazing that we simply pass these students on up. And it's a disgrace not just to the school system, but it also is a disgrace for the life prospects of these individuals, because they're given a substandard education in high school, and when they go to college, they make up the deficiencies of high school in the first year of college. So we do have a good college educational system that tries to compensate for the weakness in our high school system. And then, of course, we have H-1B. We have the cream of the cream from other countries pouring into the United States, hoping to get a job in Silicon Valley, hoping to create new industries. You see, these workers are at the high end. They're not replacing American workers because those workers don't exist to a large degree, but these foreign immigrant workers create new industries because of their science and because of their training. They want to come to Silicon Valley. They're entrepreneurs. They want to start new companies to capitalize on some of the research they're doing. This is at a very high level. And let's talk about this. In the United States, 50% of PhD students in physics, my field, are foreign-born. I repeat, 50% of the PhD students in physics in the United States are foreign-born. And if you take a look at CUNY, the City University of New York, where I teach, we have 250,000 students, making CUNY one of the largest educational institutions in the United States, with 250,000 students, and 100% of our PhD students in physics are foreign-born. Now, I do a lot of traveling. And I went to Russia one year, just a few years ago, and we had an audience with Medvedev, the president of Russia, and he was very blunt. I was rather amazed. Usually when you meet foreign dignitaries, they give you a lot of platitudes and not much more. But he said something which I thought was fascinating. He said, first of all, Russia has some of the most advanced scientists and science education in the world. They produce top scientists. And I know a lot of the people I know who are scientists are from Russia, and they are some of the top scientists in the field. And then Medvedev said, yes, we have the top scientists. We have a great educational system, but we have a problem. We have a big problem. And then he said something which sent the jaws of the audience racing to the floor. He said, we have great scientists, we have great educational system, but these scientists want to leave. They don't want to stay. There's a brain drain. And where does this brain drain lead to? it leads to Europe and especially into the United States. In fact, the United States has been able to capture some of the cream of the old Soviet system, and they are now leaders in American science today. And so America is a magnet. And the magnet, of course, has to have a conduit, and that conduit is the H-1B visa, the so-called genius visa. If you are a PhD in physics or computer science, off you go right to Silicon Valley and other major institutions. And why doesn't China then create its own Silicon Valley? Well, there are problems. First of all, in Asia, we have the expression that the nail that sticks out gets hammered down. So if you're a future Bill Gates or a future Steve Jobs, and you're the nail that sticks out, what happens to you? You get hammered down. Now, I know this because in China there is an exam called the Cuspia exam. It takes the cream of the cream of the cream of over 1 billion Chinese in physics and sends them to the United States and other institutions. I know this because I'm on the Cuspia committee. One of my students was a Cuspia student, and I tell you, yes, they're very good. When I told my PhD student to do something, he did it. No ifs, ands, or buts. They're very confident, they're very proficient, but they're not very creative. And that's one reason why the Chinese will beg, borrow, or steal as many U.S. patents and designs and ideas as they can. China is like a vacuum cleaner trying to get, legally or illegally, as many blueprints, as many patents as they possibly can to compensate for the fact that the nail that sticks out gets hammered down. In other words, China is not a leader in this technology. They're a follower. They're a copier. They're like a gigantic Xerox machine, but they do a very good job at that. They have top scientists who can follow orders. They're very patient. They're not creative. They're not imaginative. They're not innovative, but they can do the work. Now, in the United States, we have a different cultural expression. In the United States, we say the squeaky wheel gets the grease. And who are the squeaky wheels? Well, people like Bill Gates, Steve Jobs. They are the kids that stick out. They're kind of sassy. They kind of like rebel to a degree, but they're highly creative and they're very competent, and they're able to translate some of this rebelliousness into products that can create things like Amazon or Facebook or any of the gigantic Silicon Valley companies. And so you have to realize that, yes, we have a cultural advantage. We have a very freewheeling spirit that a lot of scientists overseas would like to exploit. They would like to come here. They want to create industries and be entrepreneurs. However, there are voices in Congress which say that, well, these H-1B scientists will take jobs away from American workers. Well, I don't think so. Now, let's take a look at the long-term picture, the historic picture. Was America always like that? Did we always have a Silicon Valley? Did we always have a scientific establishment that was the envy of other nations? And the answer is obviously no. In fact, for most of American history, we were the backwash of the world in terms of science. In fact, one of the reasons why Benjamin Franklin was so celebrated in France was because, yes, Benjamin Franklin was a scientist. He made pioneering discoveries on electricity, but he was a novelty. He was from the forest. The people in France thought of him as the oddball, the guy from the forest that struck it rich and became a world-renowned scientist almost by accident. So he was considered the exception to the rule. Now, of course, we had Thomas Edison, and he was, of course, one of the great scientists and great inventors of the past. But if you take a look at our output scientifically, going back to the 1920s and 1930s, it was almost zero. Let's do a science experiment. Go to any university library and go to the journal section. And you can summarize every single journal article in science written by an American scientist in a volume that was perhaps only 2 or 3 inches thick. And that represents the entire year's output of science from the United States. You can quantify. you can actually quantify how vigorous or how empty our scientific establishment was in the 20s and 30s by simply counting the number of inches per year of journal articles that America produced. It is pitiful, absolutely a disgrace. So what happened? What happened was World War II happened. All of a sudden, we had oceans of European scientists, a lot of them Jews, coming to the United States, people like Albert Einstein, people that eventually would win the Nobel Prize in physics, the people that essentially built the atomic bomb. In fact, they were my professors. Many of my professors were the ones who built the Hiroshima and the Nagasaki bomb. And they were the ones who fled Nazi Germany and came to the United States. When they came here, they realized that the United States was really the backwash when it came to science. But by going to the library of any institution and measuring the inches of articles that were published per year by American scientists, you see that there was an explosion dating from the 1950s. All of a sudden, the United States was becoming a scientific powerhouse. Germany and England, which dominated physics and science and math for over a century, their scientific output became very small, while the United States scientific output became huge as a consequence. In the 1800s, for example, it was England that dominated science. We had people like James Clerk Maxwell, Michael Faraday. We had scientists that pioneered the harnessing of electricity and magnetism. In the 1900s, we had the rise of German scientists. We had Max Planck. We had Albert Einstein, Erwin Schrödinger, people that came out of the German Empire, and these individuals pioneered atomic physics and eventually relativity. And so, again, in the 1800s, electricity and magnetism was pioneered by British scientists. In the 1900s, it was German scientists that pioneered nuclear science. But then, in 1945, it all collapsed. England and Germany pretty much destroyed each other. Their scientists fled for their lives. They came to America to create our scientific establishment. And that's why we owe a tremendous debt to immigrant scientists. Write a list of all the immigrant scientists that won the Nobel Prize, and you realize that, yes, none of them were born in this country. All of them came from overseas. Now, the point I'm raising is simply very simple, and that is, let us not kill the goose that laid the golden egg. For example, I once visited Singapore, give a talk there, and I had a chance to listen to a talk given by Lee Kuan Yew, the former Prime Minister of Singapore. And he said that in 1945, Singapore was devastated by the war. It was known as a backwash of everything. It was famous for pirates and opium and not much else. But he and a bunch of other people realized that science and technology was the way of the future. They began to invite scientists in. They began to consult with scientists. They said that an educated population can lead in software, lead in computer science. And now Singapore is one of the richest countries in the world per capita, and they're still recruiting top scientists. Everywhere he goes, he said, he would try to go to the science centers. He would go to Silicon Valley, learn from Silicon Valley, copy it, and try to bring in as many scientists as he could, because he knew that science was the ultimate engine for wealth creation. And the wealth we see when you visit Singapore, Singapore is like the Manhattan of Asia, you realize that all of it came from science and technology. But you see, politicians have a different point of view. Lee Kuan Yew was a politician, Prime Minister of Singapore, but he had a different point of view from most politicians who believe that there's a zero-sum game, that taxation will level things out, that where does wealth come from? It comes from taxes. You tax Peter to pay Paul, that's where wealth comes from. Well, I don't think so. Science is not a zero-sum game. Science creates wealth. It is a wealth generator rather than a consumer of wealth. So taxation will only get you so far. Beyond that, you have to have an enlightened scientific establishment, and as I said, most of them happen to be immigrants. Well, now let's say a few things about the planet Mars. How do we know so much about the planet Mars, especially its geology? Well, of course, we've landed on Mars. We have satellites going around Mars, but we also have Mars rocks. That's right, rocks from Mars. What happens is meteors will plow into the Martian landscape and hurl tremendous amounts of debris into outer space. It turns out the escape velocity of Mars is not that great, and rocks will be hurled into outer space, the debris left over from a meteor impact. Well, they'll drift in outer space for a while, and eventually some of them will land on the planet Earth. When we pick them up, we cut them open, and we identify the fact that they are from Mars. Now, how do we do that? Very simple. Meteorites come in different categories. You have carbonaceous, you have iron, nickel meteorites, quite different. But Mars rocks is different from all of them. We know what the Martian atmosphere is like. We can sample its atmosphere. We know what some of the rocks look like. For example, a lot of them have very similar silica structure to rocks found on the planet Earth. And then you take these meteorites from outer space, cut them open, look at their air content, and compare them with known asteroids. And you find that these don't agree at all with most of the asteroids. They're oddballs. These handful of meteorites that we found that do not fit the normal categories, they do precisely fit the profile of rocks from Mars. Bingo. That's how we do it. The air content, the mineral content differs from ordinary meteorites from outer space, and they are a direct match to what is known about the Martian soil and the Martian atmosphere. Well, lo and behold, a handful of these meteorites have hit the Earth. The recent one was in 2012. It landed in Algeria, and scientists are now publishing data from the latest meteorite from Mars. Yes, it's from Mars, and it shows that long time ago there was tremendous volcanic activity. In fact, some volcanoes lasted for billions of years, which is quite unusual. Volcanoes on the Earth do not last for billions of years. Among, for other reasons, we have continental drift that actually moves the volcano. But on Mars, the volcanoes are quite stationary, erupting for billions of years, and that gives us more of an understanding of the ecology and the geometry of Mars. And realize that in the 2030s, we're going to send humans to the red planet. Not just one, not just two, but three major governmental and private agencies have said that Mars is the target. First, we have NASA, already testing its SLS booster rocket and Orion space module to go to Mars. Second, we have Elon Musk and SpaceX, a brash billionaire who says he'll beat NASA and he'll send his modified Falcon rocket to Mars starting next year. Starting next year, he's going to go to Mars with an unmanned space probe, and after that, he wants to have luxury liners and cruise ships, believe it or not, cruise ships going to Mars to create the first city on Mars. Well, no one accused Elon Musk of thinking small. He's already talking about cities on the planet Mars. And then we have Boeing. Yes, Boeing, the same manufacturer of the Saturn rocket. Boeing is now in the picture, and they have stated they're going to beat Elon Musk to the red planet. So we may have a traffic jam around Mars in the 2030s. Other nations have said they're going to send probes to Mars, including India, which had a successful launch to Mars. Japan, many other nations say that they too want to send unmanned space probes to Mars. So we could have a traffic jam over Mars in the coming years. So this is for real now. We're talking not just about a pie in the sky. People are now talking big bucks. They're now calculating how much it would take to send the first mission to Mars. And so we're now way beyond the phase of simply dreaming about Mars. People are now putting money on the table, estimating what it would take to go to Mars. In fact, we had two astronauts, one of whom came back from outer space, and we can compare his blood, his tissue, and his bone structure with that of his twin. And we now realize that, yes, there are going to be problems. People going to Mars are going to experience weightlessness, perhaps up to 2 years on a journey to Mars. They're going to have problems with loss of calcium. They're going to have problems with cosmic rays and radiation, micrometeorites, not to mention sheer boredom, because, of course, you're going to be in cramped corners with people that you may not even like or care for, and you're going to have to live with them in cramped quarters for 2 years. 6 months to 7 months to go to Mars, a few more months to do experiments, and another 6 to 7 months to come back from the red planet. And now let me say something about the Antarctic. As we said before, we're keeping track of a crack in Larsen Ice Shelf C that is growing bigger by the day. In fact, it grew 17 miles just in the last 2 months. It means that the Larsen Ice Shelf C will eventually crack. The latest estimate is in a few more months. Watch for it. In a few more weeks to a few more months, a gigantic chunk of ice the size of Delaware will break off from Larsen Ice Shelf C. Larsen Ice Shelf A and B have already broken off, and now we're waiting for the third, the larger one, to break off. Now, I should point out that this does not mean that sea levels are going to rise immediately. These ice shelves float on water, and therefore, even if they melt, it's not going to raise the level of seawater. But what's behind the ice shelf? If the ice shelf breaks off, what's behind the ice is the ice sheet. If the ice sheet, that is the glacier itself, begins to slide into the ocean, that will definitely raise sea levels. And that's why people are concerned. Again, Larsen Ice Shelf C is about the size of Delaware. We expect it to break off perhaps in the next few weeks, the next few months. It'll make headlines when it does so, but it's not going to immediately affect the level of seawater because it is floating. However, the ice sheet behind the ice shelf sits on land, and if the ice shelf slides into the ocean, it means that eventually the ice caps and the ice sheets will also slide into the ocean from land into the ocean, and that will definitely raise sea level. And in fact, if you think about what would happen if the Antarctic were ever to melt in the next few centuries, it would mean that most of our great cities would be underwater. Think about that. And just last week, the United States government released a report stating that in the next several decades to centuries, we will witness the inundation of our great cities. Wall Street, for example, in Lower Manhattan will go underwater. Boston, Miami, New Orleans, San Francisco, L.A. We're talking about many of our great cities in the coming decades to centuries will be underwater. Of course, nations will try to build dams and levees to keep the water out, but that's only a temporary measure because you cannot sweep back the oceans. It's simply too much to expect that you can go up against Mother Nature. Well, I'm afraid that's it for exploration. In the second half of exploration, we're going to continue our discussion of the planet Mars. We're going to bring on Dr. Robert Zubrin, one of the leading advocates of a manned mission to the red planet. And we're going to talk about how dangerous it is, what kind of benefits we'll get, and what it's like to live on the red planet. And so once again, our special guest will be Dr. Robert Zubrin. He's a former aerospace engineer, one of the pioneers of the Planetary Society, talking about going to Mars. Is it really worth it to go to the red planet? Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is the second half of Exploration. In this segment of Exploration, we're going to talk about the planet Mars. Now, of course, the planet Mars has been like a magnet for science fiction writers and visionaries ever since the 1800s, when scientists began to take a good look at the red planet. In fact, it was in the last century that Edgar Rice Burroughs began to fantasize about heroes and princesses on Mars with the John Carter of Mars series, along, of course, with his earlier Tarzan series. And it turns out that an astronomer, Percival Lowell, started the stampede to look at the planet Mars by claiming that there was evidence of life on Mars, that canals on Mars represented the last-ditch effort of a dying civilization to irrigate the planet that was gradually becoming a desert. Well, now we have detailed photographs of the planet Mars. In fact, we know more about the surface of Mars than we do about the surface of the planet Earth, because most of the Earth's surface is covered in water. First of all, there are no canals. We know that because we have detailed photographs of Mars, no canals, no sign of intelligent life. In fact, no sign of life at all on the planet Mars. So if Mars is a desolate, frozen desert with no evidence of life at all, then why even bother to think about trying to colonize Mars? Well, Carl Sagan, who I interviewed for Exploration, said that in the long term, we have to become a two-planet species. That is, it's simply too dangerous to put life just on one planet. Of course, there's no rush. We don't have to have a crash program to do that. But there's no particular rush. But at some point, we will have to leave the planet Earth. On a scale of thousands of years, we have to worry about a new ice age. We have to worry about volcanic eruptions. We have to worry about meteor impact craters. We have to worry about a gigantic planet-killing, life-killing asteroid or comet that could hit the Earth on a scale of 50 million years. And then on a scale of 5 billion years, the sun will eat up the Earth whole. We came from the sun, and we will go back into the sun. The Bible says, from dust to dust, ashes to ashes. Scientists say, from stardust we came, and to stardust we will go back. And it means that at some point, we will have to either leave the Earth or die. That's a law of physics. And so some people say, well, let's begin the process of now. Other people say, well, what's the big rush? Well, one possibility to go to Mars is real because of the fact that the cost of going to Mars has dropped drastically down in the last several decades. I remember when George Bush I talked about going to Mars by 2020. That was his target to go to Mars, but the estimates were $200 to $500 billion. And that's back then. You can imagine what that would be cost, what it would cost today with those dollars, perhaps $1 trillion to go to Mars. Well, since then, we've learned a few tricks. Since then, SpaceX is pioneering things like the reusable rocket to bring down the cost. And now instead of $200 billion, people are saying, well, maybe $10 billion, we can begin the process of a manned piloted mission to the red planet. Well, with us here today is someone who's done the math, someone who's done the pioneering work, a founder of the Mars Society, Dr. Robert Zubrin, a former aerospace engineer. And we're going to ask him what his opinion is about going to Mars and what we're going to do once we get there. And now I'd like to introduce our special guest for today. We're delighted to have with us Dr. Robert Zubrin. He's an aerospace engineer and author of several books, including The Case for Mars and Mars on Earth. That's right. We're talking about President George W. Bush's Mars Initiative, and the question is, should we send humans to the planet Mars? Some people say it's too dangerous, it's too expensive, and there are other priorities. Other people say, let's go for it. So once again, our special guest today is Dr. Robert Zubrin, author of the book Case for Mars, founder of the Mars Society, and we are talking about whether or not we should put humans on the red planet. The first question for you, Dr. Zubrin, is how did you first get interested in science?
Well, actually, it was Sputnik. I was 5 years old at the time, and I was already reading science fiction. And while to the adult world, Sputnik was a terrifying event, or so I'm told, to me anyway, it was exhilarating because what it meant was that all these stories I was reading about the spacefaring future were going to become real. And I wanted to be part of it. And so I dug into every science book I could find. And, you know, my father got me a telescope when I was 7, and, you know, Kennedy gave his speech committing us to the moon. when I was 9, and, during my teen years, we were moving out. We landed on the moon when I was 17, and there was a great adventure underway, and I wanted to be part of that. I think if we were to have a Humans to Mars program today, it would encourage millions of people today to want to enter science.
And I understand you were an aerospace engineer for a while. Could you elaborate? And then how did you go about finding the Mars Society?
Well, I still am an aerospace engineer. That's what I do for a living. I used to work for Martin Marietta and then Lockheed Martin, and then I founded my own company, Pioneer Astronautics, which does technology research and development on contract for NASA and the Air Force. And that's how my source of income, and that's my professional preoccupation. I don't get any money from the Mars Society. But the Mars Society was founded by me and a number of other people who, for a long time, had believed that the American space program needs a goal, and Humans to Mars should be that goal, both for scientific reasons and for inspirational reasons and for societal reasons. I wrote a book called The Case for Mars in 1996. I got 4,000 letters from people who read it from all over the world, asking me all kinds of things, but basically asking, how do we make this happen? And when I showed this to the other folks in what was then called the Mars Underground, we decided the time had come to pull all this talent together and form an organization so that there would be a force in being that could actually try to make Humans to Mars happen.
Okay, well, let's talk about Mars as a planet and also Mars from science fiction. If you read all science fiction novels, they do say that Mars is a desert, but they said that this is a desert populated by Tharks and Martians and all sorts of different denizens and aliens. So first of all, tell us a little bit about the geology and atmosphere of Mars.
Okay, well, Mars is a desert today, although as we're now learning, it wasn't always so. It's a frozen desert. It's a polar desert, like what we have in the Canadian Arctic. And, in fact, the Mars Society has built a Mars station in the Canadian Arctic to learn how to explore these kinds of environments. It's unlikely that there's life on the Martian surface today, but we can identify places on Mars. And, of course, the news this week is that we have identified for sure places on the surface of Mars that were once warm and wet and that could have supported life. And that makes Mars really the Rosetta Stone for letting us know whether the conjecture that life originates as a natural development of complexity from chemistry wherever it has an acceptable environment, whether that is true or not. If that's true, then life is plentiful in the universe. If it's not true, if there's an element of miraculous chance involved in forming these DNAs and RNAs and all these other very complex molecules, then we could be alone. And Mars is the critical test that's going to let us find out by looking for fossils on the surface of Mars and by drilling down into the ground and reaching groundwater where there might still be extant Martian life today.
Okay, well, for those people who saw Arnold Schwarzenegger in the movie Total Recall, they know a little bit about Martian ecology. It's very cold up there, and the atmosphere is very thin.
Yeah.
And so the question is, what would it take for an astronaut to live on Mars, given the fact that it's cold, the atmosphere is like 1% the atmospheric pressure of the Earth, and there are huge sandstorms on Mars. So tell us a little bit about what it would like to live on Mars.
Okay. Well, as you point out, the atmospheric pressure on Mars is much too low to allow an unprotected human to walk around on the Martian surface today. So you would have to wear a spacesuit when you went outside. When you're inside, you could be inside of your habitat modules, which are like big tuna cans with life support systems in them, and you would live in them in a shirt-sleeve environment. It's actually, the temperature extremes on Mars are worse than the Earth, but much less bad than the Moon. Actually, on Mars, in the middle of the day, it gets to about 50 Fahrenheit. At night, it might go down to minus 130, so probably be a good idea to stay inside at night. The dust storms on Mars occur periodically, but actually, because the Martian air is so thin, these high winds up to 100 miles an hour don't have that much dynamic pressure. The 100-mile-an-hour wind on Mars has about the same force as a 10-mile-an-hour wind on Earth. So they're not really a threat, except if they're happening while you're landing, and then you have a big parachute out, which could be seized by such winds. But if you're on the ground, you could weather them quite easily, and the Viking landers weathered many dust storms without any difficulty at all.
And I understand the gravity is weaker, and the day is about similar to a day on the Earth. So tell us a little bit about what it would be like in terms of the day, the seasons, and the gravity on Mars.
Well, the gravity on Mars is 38% that of Earth. So if you weighed, 100 pounds, on Earth, you'd weigh 38 pounds on Mars. So that's an advantage. It means that if you're walking around with a big, heavy spacesuit, let's say you weighed 150 pounds and your spacesuit weighs 200 pounds on Earth, you wouldn't be able to walk around in that on Earth. But on Mars, okay, the total mass is 350 pounds, and it would only feel like about 110 pounds. So you would actually feel lighter on Mars, even wearing that spacesuit, than you would if you were on Earth naked. So that's an advantage. The day is 24 hours, 37 minutes long. So it's really just like an Earth day. People can adapt to that quite easily. And it's all one of the things that make Mars attractive for settlement, because you could grow plants in greenhouses lit by natural sunlight, since the diurnal cycle of light and dark would be very similar to Earth. This is, for instance, not the case on the Moon, where you have 14 days of light and 14 days of dark at a time, which is unacceptable to most plants.
Okay, and also tell us a little bit about the water. You said that Mars once upon a time had flowing rivers and perhaps even an ocean, but what happened?
Well, it's not completely clear what happened, but the dominant theory is as follows. Okay, that Mars in its early history was warm and wet because it had a thick CO2 atmosphere, which made a very strong greenhouse effect on the planet. You know, people are talking about global warming on the Earth due to CO2 emissions from industry. Well, and that can warm a planet because CO2 traps heat. On Mars, you had a much thicker CO2 atmosphere, so much so that even though the planet was farther away from the sun than the Earth, it was still warm enough for liquid water. So a greenhouse effect, bad on Earth, but good on Mars. Now, the problem, though, with Mars is that the planet is too small for plate tectonics. And the reason why this is an issue is the following, that when you have rain, as you did in the early Mars, and you do on Earth, of course, CO2 dissolves readily in water. It gets taken down by the rainwater into the ground, where it reacts readily with rocks to form carbonates. Now, on Earth, those carbonates are recycled back into the atmosphere through the motion of the geology, through plate tectonics that melts all rocks on timescales of around 100 million years and returns the CO2 back into the biosphere. On Mars, once the stuff gets locked up as carbonates, it's pretty much locked up. So the CO2 atmosphere on Mars started to thin out over time. Now, as it thinned out over time, Mars started to cool because the greenhouse effect got weaker. And when it reaches a certain low temperature, then soil has the capacity to sponge in CO2. Adsorption is what it's called. And once absorption begins, that thins out the atmosphere much more rapidly than carbonate formation, and you get a runaway icebox effect, where the more CO2 is absorbed, the colder it gets, the more is absorbed, and wham, the whole planet freezes up. And it's been in deep freeze now for perhaps 3 billion years.
Dr. Zubrin, some scientists have said that there is the potential of creating an artificial greenhouse effect on the red planet, which would then raise the temperatures on Mars. Could you elaborate?
Now, someday, human settlers on Mars, when there's enough of them and they have enough industrial capability, could conceivably set up factories on Mars for producing artificial greenhouse gases like fluorocarbons. You don't want to do chlorofluorocarbons because they destroy ozone, but fluorocarbons don't destroy ozone, and but they're very powerful greenhouse gases. And if you produce them and you warm the planet up around 10 degrees C through your own efforts, that would warm the planet enough that CO2 without gas out of the soil and start adding to your greenhouse effect, and we could raise the planet by 50 degrees centigrade. We could create a Mars whose tropical regions were tropical, and in which there's liquid water on the surface again. And while you couldn't breathe that atmosphere because it'd be almost all CO2, plants could, and you could put plants on the ground outside. There'd be rain. There'd be water cycling, and you could start to green Mars. It'd be a tremendous accomplishment of positive environmental engineering.
Okay. Well, also tell us about the ice caps of Mars. Some people think that some of the water snowed on the ice caps. Other people think that the water is still there underground in the permafrost. Could you elaborate?
Yes. Well, there is water on Mars, and almost undoubtedly in both of those locations. We can see the northern polar ice cap on Mars is water ice. And it looks like people thought the southern ice cap might have been mostly CO2 ice, but measurements that we've taken from our orbiters indicate that it's at least 60% water ice as well, and possibly all water ice. And then we can see geologic features that look like water bursting out of the sides of craters in a geologically recent period, which means there has to be subsurface aquifers of liquid water that occasionally break loose. So that's one reason why you really want to send human explorers to Mars, because if we're going to find life on Mars, actual living organisms, not just fossils, we're going to have to set up drilling rigs and reach that groundwater. Then you want to take that water into your habitat on Mars, throw it into bacterial culture medium, see if anything grows. If it does, image it in your microscopes, test it with biochemical testing, see what it's like, see if it mimics the biochemistry of Earth life or if it's something different. This is something we really want to know. We really want to know if all life as it is in the universe is the same as Earth life, since all Earth life is biochemically the same. They all use the same amino acids and the same RNA and DNA method of transmitting information, or are there other methods of creating life? So this is one of the fundamental questions in science today, and the way we're going to resolve it is by going to Mars.
Well, we don't see any liquid water on Mars today, but some people think that perhaps there could be underground geysers or underground hot springs due to volcanic activity, in which case there could be pockets of liquid water even today. But what are your thoughts?
Well, as I said, the geomorphological evidence is that there is underground liquid water on Mars today, because the Mars Global Surveyor orbiter took pictures from orbit that showed channels that have been cut out from the sides of craters from water bursting out from the side, and these things are totally uncratered themselves, which means they happened in the past few million years, which is basically, from the geological point of view, today. So if water could burst out of the side of a crater 4 million years ago, it could do it tomorrow. And that means there has to be liquid water underground on Mars now.
Okay, now let's talk about the robotic exploration of Mars. Some scientists have called Mars the death planet because so many Mars missions have failed. However, we now have rovers on the surface of Mars looking at rock formations. What have they found specifically that has excited the imagination of scientists, the two rovers on Mars?
Okay, well, let me just point out that 12 out of 16 American spacecraft sent to Mars have succeeded. Okay, 4 out of 5 of our landers have succeeded. The reason why the Mars statistics are so low is because the Russians sent 14 spacecraft to Mars, and all of theirs failed. But in terms of our own record with regard to Mars, we're batting around 700. Now, what have we found? Okay, well, from orbit, we have found water erosion features all over the place, dry riverbeds, dry lake beds, what looks like perhaps the basin of a dried-up northern ocean. On the ground, what we just found this week is that these water features were not created by water that was just there in some flash floods that lasted an afternoon and then the water was gone, which is what some people had been suggesting. But rather, this water was there for a long period of time. We found what the Opportunity rover has found are what's called evaporites, that is, residues left when water evaporates and the salts in the water and the sulfates in the water have been left behind. This requires standing bodies of water that exist for long periods of time and stay in place long enough for the water to evaporate away. And what's very conclusive, what we've learned from these robots, is there have been places on Mars where life could have developed. And now the key question is, did it?
Okay, now let's talk about the practical implications of sending men to Mars, as advocated by President George W. Bush. First of all, let me play devil's advocate. Let's talk about cost. We know we could do it. We just put enough money into it, throw money at it, and we could put men on Mars. George Bush Sr., when he proposed a manned mission to Mars, numbers that were being thrown out were on the order of $500 billion. What do you think it would cost under your program to put men on Mars?
I think we could have people on Mars within 10 years for $40 to $50 billion. The issue here is actually constraining the problem in the way President Kennedy did with Apollo, where you put a timeline on it, and you say, you've got to do this within a decade. And so you don't just launch a plethora of programs and say, well, this might be useful for someday in the future when people go to the moon or to Mars, and this might be useful. Instead, you sit down, you design an end-to-end plan for how to do it, you design a coherent set of hardware elements to implement that plan, you develop those hardware elements and the associated technologies and no others, you build them, and you fly the mission. If you do that, you can be on Mars in a decade. If you don't do that, you can spend any amount of money you like, and you can spend decade after decade, and you'll have no progress at all. And this is the difference between the NASA of the Apollo period, basically from 61 to 73, and the NASA of the 3 decades since. It may startle people to learn that NASA's budget this year is something like 94% of what its average budget was during the Apollo period in real inflation-adjusted dollars. That is, the average Apollo period budget in today's money was $17 billion a year. NASA's budget this year is $16 billion. And we spent as much money in NASA between 1990 and today as we did between 61 and 73. But in that earlier period, we developed all the space technologies we have and that we use, and we sent people to the moon, and we sent 40 lunar and planetary probes out. In the period between 1990 and today, we developed no new space technologies. We did not fly anyone to the moon or anywhere like that, and we flew maybe, 7 or 8 planetary probes. So when you actually have a goal and you force the organization to address that goal rather than use that goal as a rationale for doing whatever it pleases to do, except for the goal, you can really accomplish something.
Okay, now one of your plans, which is controversial, is to give our astronauts a one-way ticket to Mars, have them develop rocket fuel themselves for the return trip. So tell us a little bit about how that is done in order to reduce costs.
Okay, this is known as the Mars Direct Plan, and it's explained at length in my book, The Case for Mars. The way this works is you do this mission with 2 launches of a heavy-lift launch vehicle of equal capability to the Saturn V moon rockets that we used in the 60s. The first rocket shoots to Mars an Earth return vehicle with no one in it. Now, that goes out and that lands on Mars. Then you run a pump and you suck in the Martian air, which is mostly carbon dioxide gas. You react that carbon dioxide with a small amount of hydrogen that you brought from Earth to produce a large supply of methane oxygen rocket propellant. So now you have a fully fueled Earth return vehicle sitting, waiting for you on the surface of Mars. Once that is done, then you launch the crew out to Mars with the second rocket. Okay? Now, because the return ride is waiting for them on the surface of Mars, they don't need to fly to Mars in a gigantic Battlestar Galactica spaceship that nobody knows how to build. Okay? They can just fly to Mars in a basic habitation module, like a big tuna can, flies out to Mars. It takes 6 months to get to Mars with chemical propulsion. We do not need nuclear propulsion to get to Mars in 6 months. Mars Odyssey did it in 2001. In 6 months, we can get there right now with this. We go to Mars. We land near the Earth return vehicle. We use the same habitat that we used as our ship to go to Mars to be our house on Mars for a year and a half while we explore the planet. And then, at the end of that time, we get in the Earth return vehicle and we fly back to Earth. We leave the habitat behind on Mars. So each time you do this, you add another habitat to the base. And before long, you've built up the beginning of the first human settlement on a new world. There is nothing in this that is beyond our technology, and I might add that the risk associated with this plan is much lower than that of the conventional mission, because the conventional mission involves extremely complex on-orbit assembly of mega spacecraft, which has much lower quality control than you can ever have on the ground at the Cape, integrating the much smaller spacecraft that are required for this mission. And furthermore, the return vehicle has already been landed on Mars before you leave Earth, and that's actually safer than the conventional mission in which you attempt to land on Mars in the vehicle that you hope to take off from. In other words, here you know before you've even left Earth that you already have an ascent vehicle that has survived the trauma of landing on Mars. In the other mission plan, you don't. So this plan is doable with our technology. It's much less costly than the standard plan. It's much less risky than the standard plan. It accomplishes a lot more science than the standard plan because all the crew is on Mars, no one is left in orbit, and we've got the technology to do it. So all it takes is some vision, some guts, and a little bit of moxie.
Okay, well, I was watching CNN television the other day, and the commentator said, well, the Mars rover is going on Mars, but what did it find? Rocks. Rocks, rocks, and more rocks. And what he was implying, therefore, is that there's really not a pot of gold out there. There's really no reason to spend any more money on the mission to Mars. So let me ask you a question. What are the economic benefits? Why go to Mars if it's an enormous amount of money for a goal that is a little bit dubious?
Well, the goal is not dubious at all. And saying there's nothing on Mars but rocks is like saying in 1600 there's nothing in North America but trees and animals. I mean, it's an extremely anti-intellectual and stupid statement. What there is on Mars is a world. It is a planet with a surface area equal to all the continents of the Earth put together. And it has on it all the resources needed to support life and therefore potentially human civilization. And if we can go to Mars and develop the technologies that allow human beings to be self-sufficient in this environment, as, previous generations of our ancestors, starting from those who left Africa to take on Ice Age Europe, did, human beings have used their creativity to master environments that were previously considered uninhabitable.
Well, I'm afraid that's it for Exploration.